Alright, so this is number 4. So we have log of the cube root of x plus 2 divided by x to the 4th times x squared plus 4. Alright, so first things first, let's rewrite this cube root as an exponent. So we have log of, rewrite everything, x plus 2 divided by x to the 4th times x squared plus 4, all raised to the 1/3 power. Alright, remember, so we're going to break this up. So remember, we have an exponent, you move it to the front. So that's 1/3 log of the same stuff. Too lazy to rewrite everything. Alright, so now we know what we have to do here. So we have a division and a multiplication. So when you divide, you subtract. When you multiply, you add. Alright, so we have 1/3 of, so we have log of x plus 2, and then divided by, minus, my fault, minus, so write parentheses. Now we have to write this difference. So we have log x to the 4th plus log of x squared plus 4. Okay? Alright. So let's do that again. So the 1/3 stays in front. Now we break down this. So you divide first, right? Is this divided by that? So that's where I have the subtraction of the bottom part. Now, log x to the 4th plus log x squared to the 4th. Plus 4, because these two are being multiplied. Okay. So now we can go a little bit further, and it'll be 1/3 times log of x plus 2 minus, again, this has an exponent, so we can bring it out to the front, and then x squared plus 4 just stays x squared plus 4. Alright, and that's it. That's the best way to do that one. Alright, let's look at the next one. The next one says number 5. Number 5 says natural log of x minus 2 natural log of x squared plus 1 plus 1/2 of the natural log of 3 minus x to the 4th. Alright. So the best way is to go left to right, just like with PEMDAS, we go from left to right. Alright. Since it doesn't have parentheses around here, we can't assume they're the same, they're together. I think. I'm pretty sure, yeah, that's the way it works. Yeah. Alright. So we're gonna have, hold on. Let's see. Suppose that'll be minus and a minus, so that divided by that divided by the other one. This is parentheses these first. Alright. Yeah. Come on now. Alright. Cool. So let's rewrite this. So it's gonna be ln x minus ln of x squared plus 1 divided by 2. Alright, so we can combine these two first. This stays the same. So we combine this to ln of x over x squared plus 1, that thing squared. Then you have plus, you write this as ln of 3 minus x to the 4th raised to the 1/2. So plus ln of 3 minus x to the 4th to the 1/2. Alright, since you are adding, that means you have to multiply. So you have the natural log of x times the square root, remember 1/2 is the square root of 3 minus x to the 4th divided by x squared plus 1, the whole thing squared. Okay, so first things first, you divide these two, or you put this back up here, You divide them and you get this, and then since you're adding the next log, it means you have to multiply the log, and that's it for yeah, number 5. Okay, so again, you always go left to right, left to right. You don't try to multiply and then divide. You always go left to right, just like PEMDAS says. You always go left to right. Okay, so ln x minus 2. So you have to divide these two first, and we got this. And this is you're adding. You have to multiply that. Okay, always go left to right first. Always. All right. Next one is we have to find the solutions correct to do decimal places. I don't have a calculator, so you're gonna have to do a lot of these calculations yourself. It says 2x minus 1. I'm just gonna show you the math. So we know we have to try to get this in the base 2. There is no base 2 of this. 2 raised to any integer will not give me 10. So what we have to do is take the natural log of each. So take the natural log of this side and the natural log of that side. Oh, come on, piece of crap. Alright, so we're going to have, so using your rules, your exponential rules, to be x minus 1 times the natural log of 2 is equal to the natural log of 10. Again, since we're solving for x, you have to get rid of the ln plus 2. The way to get rid of that is by dividing. So you have x minus 1 is equal to the natural log of 10 divided by the natural log of 2. And no, you cannot do natural log of 5. That is not correct. Okay? That is not absolutely not correct. Alright, so again, you need to get rid of that 1. So it's minus 1, so you have to do the opposite. So it's plus 1 plus 1. So in your calculator, you're going to go ahead and put natural log of 10 divided by the natural log of 2 plus 1. Okay? Alright, let's do the next one, which is B. So you have 5 natural log of 3 minus x is equal to 4. So we have to solve for this, so we have to get rid of the 5 first. To get rid of the 5, you divide everything by 5. Okay? So you have the natural log of 3 minus x is equal to 4/5. Then to get rid of the natural log, you have to raise raised to the e power. So you do the same thing. So now you'll be left with 3 minus x is equal to e to the 4/5 power. So you do a little bit of algebra. So you have 3 minus e to the 4/5 power is equal to x. Okay. You take the 3 over here and multiply both by negative, or take the x this way and then move the e this way. You get the same thing. So go ahead and put this in your calculator to get that answer to the 100th place. Alright, next one says 10 raised to the x plus 3 is equal to 6 to the 2x. So you can do this one of two ways. You can go ahead and change the 6 to 2x to 36x, or just leave it like that. It's going to be the same exact thing. We're doing both ways just to show you. It's fine. So you go ahead and take the natural log of both sides again. So you have a natural log of 10x plus 3 is equal to a natural log of 6 raised to the 2x power. So again, you have your x's. So you write this as x plus 3 times natural log of 10 is equal to 2x times natural log of 6. Yeah, it's gonna be rough. Yeah, you know what? We do have to see. We all make mistakes, man. We do have to go ahead and evaluate this one first. Let's get rid of all this stuff. Oh, come on, erase. Alright. So we do have to evaluate. That's good to know, right? Do it one way, doesn't work out. Hey, do it the other way. It's okay. It's all good. I still make mistakes. It's okay. So let's fix this. We write this as 10x plus 3. So again, remember this. breaks it into this. So this just turns out to be 36 raised to the x power. So now you take natural log of both sides. So now you have x plus 3 log of 10 is equal to x of log of 36. Oh, we still have the same problem. It's all good. Alright. So what we have here is going to be x ln of 10 plus 3 ln of 10 is equal to x ln of 36. Okay. So we have to know. So we have to do a little bit of algebra, more algebra. So let's move this x over here. So minus x ln of 10. ln of 10 is just a constant, right? It's just a regular number. So you can think about it as, I don't know, 2x. And think about this as 6x, you know? It doesn't matter. It's all going to be the same thing. So we have 3 natural log of 10 is equal to x natural log of 36 minus x natural log of 10. I'm writing my L's this way now because it's getting a little bit confusing. This looks like 1 and 1, 0. So we're not going to do that. Alright, so next step is we have to factor. So what do this and this have in common? Well, they have an x in common, right? So we write this as this. This is x times natural log of 36 minus natural log of 10. So this is a number minus a number. So you can think about this as, I don't know, 10 minus 4 is 6. So this is 6x. Pretend this is a number. Let's say this is 6. How would you get rid of the 6? It's x times 6. So to get rid of the 6, you have to divide. Okay? So we are dividing. So we're going to divide both sides by this quantity. Because again, natural log of 36 is a number. Natural log of 10 is a number. Okay, so you can think about it just as constant. So we have x is equal to 3 times the natural log of 10 divided by the natural log of 36 minus the natural log of 10. Okay, so we could have done it the other way. It would have been the same thing, but you know, it's all good. So we wrote this at 36x. You take the natural log of both sides, so we take the exponent to the front. So you're left with x plus 3 times the natural log of 10 is equal to x times the natural log of 36. You distribute the, you know what, we didn't even have to distribute here. We could have divided both sides by natural log of 10 and then taken it. No, we still have to. It's all good. No, it still would have been the same thing. Yeah. Yep. Alright, so we distributed the natural log of 10. So this is a so you want to get all your x's to one side. So you take this x over here. Then you go ahead and factor. You have x natural log 36 minus x of natural log 10. Since both of these have x's in common, you take out the x and you leave everything else the same. Since natural log 36 is a number and natural log of 10 is a number, it's just a number, so you can think about it as 6. So how would you get rid of the 6? Well, you just divide. So we divide by everything, and you get this big old sexy thing right here. So just go ahead and put that in your calculator to get the answer. All right, D. Yeah, I have enough room for D. For D, it's log base 2 of x plus 2 plus log base 2 of x minus 1 to 2. So they have the same basis and you're adding them. What you have to do is multiply. So you have x plus 2. So you have log base 2 of x plus 2 times x minus 1 is equal to 2. Oh, come on, get out of here. Alright, so just go ahead and FOIL that out. So we get log base 2 of x squared plus x minus 2. That is equal to 2. Alright. Now to get rid of the log base 2, we need to raise everything to the second power. Alright. So this will cancel out. So we have x squared plus x minus 2. 2 squared is 4. So now you take this to the other side. So you have x squared plus x minus 6 is equal to 0. So now you have to factor this out. So you need to factor this out, see what gives you 0. So this is 1, this is 6, you know it's going to be x plus 3 times x minus 2. Alright? Alright. So we have x is equal to negative 3, or x is equal to 2. Alright, so now this is when you have to check your answer. Mathematically, these are correct, but you need to plug it in to see if it makes sense. You plug in negative 3. Negative 3 plus 2 is negative 1. Right? If we say x is equal to negative 3, we have log base 2 of negative 1 plus log base 2 of negative 4. So now, can you take a log of a negative number? No, you cannot take a log of a negative number. So x minus 3 is the wrong answer. Okay? Even though mathematically it is an answer, when we plug it back into our function, it is not. It cannot possibly be an answer. Okay? Just like in physics, when you're doing the projectile motion, you know, it's the shape of a parabola. It says when does it hit the floor? Right? It is a parabola, so technically you do have two roots, right? This was 5 seconds. This was negative 2 seconds. Mathematically, negative 2 seconds is an answer, but in application, you know, there's no way you can go back. No way the rock was hitting the floor 2 seconds earlier. That doesn't make sense, right? All right, so this is it. All right, so this is, see, when you have your two answers, when you have more than one answer, or anytime you get an answer with logs, go ahead and plug it in. If you have a log of a negative number or 0, you have to make sure that you have to remember that you cannot do that. All right.